To determine the wire size for the primary, which is the 480 volt side, you need to calculate the current. The formula for this is current in amps equals power in kVA times 1000 divided by voltage in volts times power factor. Assuming a power factor of 0.8, the calculation is current in amps equals 32 times 1000 divided by 480 times 0.8, which equals 83.33 amps. Referring to the NEC table 310.16, the minimum wire size for 83.33 amps at 480 volts is number 6 AWG. Now let's calculate the wire size for the secondary, which is the 240 volt side. The formula is similar: current in amps equals power in kVA times 1000 divided by voltage in volts times power factor. Again, assuming a power factor of 0.8. The calculation is current in amps equals 32 times 1000 divided by 240 times 0.8, which equals 166.67 amps. Using NEC table 310.16, the minimum wire size for 166.67 amps at 240 volts is number 2 AWG. Next, to calculate the fuse size, it should be slightly higher than the maximum current that the load will draw. NEC table 310.15. B16 specifies that fuses should not exceed 125% of the ampacity of the conductor. Therefore, the fuse size for the number 6 AWG primary wire is 83.33 amps times 1.25, which equals 104 amps. For the number 2 AWG secondary wire, the fuse size is 166.67 amps times 1.25, which equals 208 amps. For further reading and reference, you can consult NEC table 310.16, which covers the ampacities of conductors. Also, refer to NEC table 310.15, B16, which deals with overcurrent protection. Another useful resource is IEEE Standard 141, which provides recommended practices for electric power distribution for industrial plants. These standards and tables will provide more detailed information on selecting the correct wire and fuse sizes for your specific application. Understanding how to properly size wires and fuses is essential for ensuring the safe and efficient operation of electrical equipment. The calculations take into account the voltage, current, power factor, and ampacity of the conductors to prevent overloading and potential hazards. Always consult the latest edition of the National Electrical Code and other relevant standards to ensure compliance with all applicable regulations. Proper wire and fuse sizing is crucial for protecting electrical systems from overcurrents, which can cause damage to equipment, insulation breakdown, and even fires. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current when it exceeds a predetermined level. Selecting the correct size of these devices is essential for ensuring that they will trip or blow before the conductor is damaged. The ampacity of a conductor is the maximum current it can carry continuously under specific conditions of use without exceeding its temperature rating. NEC table 310.16 provides ampacity values for various types of conductors based on their insulation type, size, and insulation conditions. When selecting a conductor, it is important to consider the ambient temperature, the number of conductors in a raceway or cable, and any other factors that may affect its ability to dissipate heat. If the conductor is installed in an environment with a high ambient temperature, or if it is grouped with other conductors, its ampacity must be derated to account for the reduced heat dissipation. The power factor is a measure of how effectively electrical power is being used. A power factor of 1.0 indicates that all of the current is being used to do work, while a power factor of less than 1.0 indicates that some of the current is being used to create reactive power, which does not do any useful work. In most industrial and commercial facilities, the power factor is typically less than 1.0 due to the presence of inductive loads such as motors, transformers, and ballasts. A low power factor can cause increased energy losses, voltage drops, and reduced system capacity. Power factor correction capacitors can be installed to improve the power factor and reduce these problems. When calculating the wire size for a particular application, it is important to consider the voltage drop in the conductor. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The amount of voltage drop depends on the length of the conductor, the current flowing through it, and the resistance of the conductor. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. To minimize voltage drop, it is important to use conductors that are large enough for the application and to keep the length of the conductors as short as possible. The type of insulation used on a conductor also affects its ampacity. Different types of insulation have different temperature ratings, which determine the maximum temperature that the conductor can withstand without being damaged. The NEC specifies the allowable ampacities for various types of conductors based on their insulation type and temperature rating. It is important to select a conductor with an insulation type that is suitable for the environment in which it will be installed. For example, conductors that are installed in wet locations must have insulation that is approved for wet locations. The NEC also provides requirements for the installation of conductors in raceways, cables, and other wiring methods. These requirements are designed to protect the conductors from physical damage and to prevent electrical hazards. It is important to follow these requirements carefully to ensure that the electrical system is safe and reliable. The selection of overcurrent protection devices, such as fuses and circuit breakers, is also governed by the NEC. The NEC specifies the maximum allowable size of overcurrent protection devices for various types of conductors and equipment. The overcurrent protection devices must be sized to protect the conductors from overheating and to prevent damage to equipment. In addition to the NEC, there are other standards and guidelines that may be applicable to the design and installation of electrical systems. These include standards from organizations such as IEEE, ANSI, and AL. It is important to be familiar with all of the applicable standards and guidelines to ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safe and reliable operation. Electrical systems should be inspected periodically to identify any potential problems, such as loose connections, damaged insulation, or overloaded circuits. Any problems that are identified should be corrected promptly to prevent them from causing more serious problems. Maintenance activities, such as tightening connections, replacing damaged components, and testing overcurrent protection devices, should be performed on a regular basis to ensure that the electrical system is operating properly. The use of appropriate tools and equipment is essential for performing electrical work safely and effectively. Electricians should use insulated tools to protect themselves from electric shock. They should also use appropriate test equipment to verify that circuits are de-energized before working on them. It is important to follow all safety precautions when working on electrical systems to prevent accidents and injuries. Only qualified and experienced electricians should perform electrical work. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely and effectively. A qualified individual should not attempt to perform electrical work, as this can lead to serious accidents and injuries. Continuing education is essential for electricians to stay up to date on the latest codes, standards, and technologies. The electrical industry is constantly evolving, and it is important for electricians to keep their skills and knowledge current. Continuing education courses can help electricians to learn about new technologies, improve their skills, and stay compliant with the latest regulations. The design and installation of electrical systems should be performed by qualified electrical engineers and electricians. These professionals have the knowledge and experience necessary to ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. The selection of appropriate materials and equipment is essential for ensuring the long-term reliability of electrical systems. Electrical components should be selected based on their performance characteristics, environmental compatibility, and life cycle costs. It is important to choose high-quality components that are designed to withstand the rigors of the application. The proper grounding of electrical systems is essential for safety and for preventing equipment damage. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to trip over current protection devices and prevent electrical shock hazards. The NEC provides detailed requirements for grounding electrical systems. The use of arc fault circuit interrupters, or FSIs, is required in many residential circuits to protect against arc faults, which are a common cause of electrical fires. FSIs are designed to detect arc faults and to trip the circuit breaker before a fire can start. The use of ground fault circuit interrupters, or GFCIs, is required in wet locations, such as bathrooms and kitchens, to protect against ground faults, which can cause electrical shock hazards. GFCIs are designed to detect ground faults and to trip the circuit breaker before a person can be injured. Energy efficiency is an important consideration in the design of electrical systems. Energy-efficient lighting, motors, and other equipment can help to reduce energy consumption and lower operating costs. The use of renewable energy sources, such as solar and wind power, can also help to reduce energy consumption and environmental impact. The proper labeling of electrical equipment is essential for safety and for facilitating maintenance and troubleshooting. Electrical panels, circuit breakers, and other equipment should be clearly labeled to identify their function and the circuits they serve. This will help to prevent confusion and errors during maintenance and troubleshooting. The documentation of electrical systems is essential for maintaining a record of the system's design, installation, and maintenance history. Electrical drawings, specifications, and other documents should be kept up to date and readily accessible. This will help to facilitate future modifications, repairs, and upgrades to the system. The coordination of overcurrent protection devices is essential for ensuring that the correct devices trip in the event of a fault. Overcurrent protection devices should be coordinated so that the device closest to the fault trips first, minimizing the extent of the outage. The use of surge protection devices is recommended to protect sensitive electronic equipment from voltage surges caused by lightning, power line disturbances, and other events. Surge protection devices divert the surge current to ground, preventing it from damaging the equipment. The testing of electrical systems is essential for verifying their proper operation and for identifying any potential problems. Electrical systems should be tested after installation, after modifications, and periodically throughout their service life. The testing should include visual inspections, insulation resistance tests, and other tests as appropriate. The emergency power systems are designed to provide power to essential loads in the event of a power outage. Emergency power systems typically include generators, transfer switches, and batteries. The emergency power system should be tested regularly to ensure that they are functioning properly. The electrical safety training is essential for all workers who may be exposed to electrical hazards. Electrical safety training should cover topics such as lockout/tagout procedures, personal protective equipment, and safe work practices. The electrical codes and standards are constantly evolving, and it is important for electrical professionals to stay up to date on the latest requirements. The electrical codes and standards are updated regularly to reflect new technologies, best practices, and safety concerns. The electrical inspections are performed by qualified electrical inspectors to ensure that electrical systems are installed in accordance with the applicable codes and standards. Electrical inspections help to identify potential safety hazards and to ensure that the electrical system is safe and reliable. The electrical permits are required for most electrical work to ensure that the work is performed by qualified individuals and in accordance with the applicable codes and standards. Electrical permits help to prevent unqualified individuals from performing electrical work, which can lead to safety hazards. The electrical contractors are responsible for ensuring that all electrical work is performed in accordance with the applicable codes and standards. Electrical contractors should have the necessary licenses, insurance, and experience to perform electrical work safely and effectively. The electrical engineers are responsible for designing electrical systems that are safe, reliable, and efficient. Electrical engineers should have the necessary education, training, and experience to design electrical systems that meet the specific needs of the application. The electrical apprenticeships are a valuable way to learn the electrical trade. Electrical apprenticeships provide on-the-job training and classroom instruction, allowing apprentices to develop the skills and knowledge necessary to become qualified electricians. The electrical licensing is required for electricians in most jurisdictions. Electrical licensing ensures that electricians have the necessary knowledge and skills to perform electrical work safely and effectively. The electrical safety is a shared responsibility. Everyone has a role to play in ensuring that electrical systems are safe and reliable. By following safe work practices, using appropriate tools and equipment, and staying up to date on the latest codes and standards, we can all help to prevent electrical accidents and injuries.